In this video, we are going to be looking at evaluating functions. So first up, we are just gonna get practice by entering in values in, and then we're going to get a little more, bigger with some of these just for some practice purposes. We won't do all of them, we'll kind of jump around. The answer key, if you need it, is attached here. Let's go. All right, so we have the absolute value of t plus 2 plus 3, and this is when h is 6. So this is saying replace t with 6. So we're going to erase this t, and if you want good habits, we can put parentheses where the t used to be, and we enter in a 6. So we have the absolute value of 6 plus 2 plus 3. Now, absolute values, think about distance. So if you get a negative value in it, you're just going to use its positive counterpart. So you have 8 plus 3, or the absolute value of 8 plus 3, which is 8 plus 3, or 11. So h of 6 is equal to 11 should be your response. Or you can write it as a coordinate. H of 6 is equal to 11. Either of those. Let's try it again here. We have WT is equal to negative 2t plus 1. When W of negative 7, so t is equal to negative 7. So inserting a negative 7 where t used to be, we have positive 14 plus 1 is equal to 15. So W of negative 7 produced a positive 15, or negative 7, 15. We'll do a few more, and maybe we might jump around here. We have negative 2, or h of n, is equal to negative 2, n squared. This n was squared, so we're just going to open up a pair of parentheses to actually fit your value in. We're looking for when n is equal to 4. So replacing that n with a 4. Orders of operation says we need to take care of the exponent first. So we have 16 plus 4. So negative 32 plus 4 is negative 28. So we have h of 4 is equal to negative 28, or 4 negative 28. We'll do just a couple more. Maybe we'll do 2 and 8, because those are a little different. So you have g of a is equal to 3 to the 3 times a minus 2, when a is equal to 1. So we are replacing your a value with 1. So we have 3 to, let's see, 3 minus 2, which is equal to 1. So we just have 3 to the first power. And that's not how you write your answer. You have g of 1 is equal to 3, or 1 comma 3. The reason why we're a little bit picky about how we're structuring your answer is that we want to know, okay, what number did we have to put in to get this 3 out? In this structure, we know that we put in a 1 into your function. Or in this one, this is a coordinate. So if you were to graph it, you can graph the coordinate 1 comma 3. So let's see, let's do number 8. So we have negative 1. So this is when we have p of a is equal to negative 4, 3 to the a. This is when a is equal to negative 1. So we're going to replace that a with negative 1. Get negative 4 to the negative 3. Now, if you have a negative exponent, we're going to change the location. So if this negative 4 is in the numerator, we're going to drop it down into the denominator. So you have 1 over We can keep that negative on the outside. And now we get to change your exponent to a positive, because you always want to have positive exponents at the end. So then you can get to evaluate 4 to the third, which is 64. So negative 1 over 64. So your final answer should be P of negative 1 is equal to negative 1 over 64, or negative 1 and negative 1 over 64. Now let's take a look at number 10. So number 10 is ever so slightly different, because now we're not just looking at numbers to put in, but instead we might do a variable or a whole term or even a bi or trinomial. So this is saying, okay, replace A with 2A. So the same structure, we have G of A, 4 times A. So leaving a gap where the A used to be, we can now go ahead and replace 2A. So this is now 8A. So we have G of 2A is equal to 8A. Let's try it again. We'll come back to 12. Let's try it again with 11. W, leaving a gap, 4 times n plus 2. This is when n is equal to 3n. So where your n used to be, we're then going to put in a 3n to make 12n plus 2. So W of 3n is equal to 12n plus 2. Let's see, are there any more that are kind of similar? Not quite, but let's see what happens when we go to insert a binomial. So in order to put in this whole thing into your function, the same rules apply. Leave a gap anywhere you have your variable. So this is just saying replace t with t minus 2, something a little bit bigger, t minus 2, t minus 2. Then we can go ahead and simplify it. So 4t minus 8 minus 5, so 4t minus 13. Oops. So P of t minus 2 is equal to 4t minus 13. Let's try that again with 13. So H for x, leave a gap, minus 2. This is when x is equal to x plus 2. So replace that x with x plus 2. So we have 4x plus 8 minus 2, 4x plus 6. So h of x plus 2 is equal to 4x plus 6. Now, if you wanted to, because future instructors, they might want you to factor out at the end. So if you notice that some of your terms have a GCF, you can go ahead and factor out what they have in common. So they both have a 2 in common. So in this case, you can take away just one of those 2's and leave behind the value that we didn't highlight. So taking out this 2, leaving behind a 2x plus 3. This is an okay response. This response is better. Let's have you try that with, let's have you try it with 18. So you have ht is equal to 2 times 3 plus 3. This is when t is equal to 4 plus t. or t plus 4. It doesn't matter which one you prefer. Let's do t, or 4 plus t. 4 plus t. So we have 2 times 3. We have 4 plus 3 is 7 plus t. So h of 4t, 4 plus t is equal to 2 times 3 to the 7 plus t. And if you're thinking, oh, I can just multiply the 2 and the 3 to make a 6, we're actually not possible. This is called your multiplier, and this is your base. Now, this is going to come out to be a certain number whenever you choose your t value. So we cannot just combine these at will. Now let's see what happens if we have something with an exponent. So let's jump to 16 here. And then let's see. Oh, it's kind of big. Yeah, we'll do this one. So I'll do 16 and then 17. All right, so this is now interesting when you have an exponent. So keep in mind, you still have this one that has your exponent, -2, and leave a gap. So this is when n is equal to n squared. So we're going to go ahead and insert this n squared into both of your gaps. Now, when you have an exponent being raised to another exponent, we're actually going to multiply them together. So 2 times 2 makes 4, -2n squared. Now, this is an okay response. Keep in mind, if you do have, if you are able to factor, factoring is always a little bit better. So a good answer is this. The better answer is to recognize that you have 4 n's here, you have 2 n's here. So highlighting, at most they have in common is 2 n's. So you could also say you have n squared, leaving behind 2 of the unhighlighted n's, -2. So this is the better response. This is an okay response. Now let's look at 17. Now I might change it because this is a lot of multiplying. So I might change ours to be a squared -5. And then if you wanted to go back and try it again with a cube, that's perfectly fine. So this is now P of A. P. We have an A there, so we're going to leave a gap. Parentheses 2 -5. Again, I changed mine for my purposes. So now we are replacing your A with x -4. So replacing x -4, x -4. So unlike last time where you could kind of just distribute in and multiply, this is saying we have 2 of these values. Just like if you had x squared, this is really 2 x's being multiplied together. So what we have to do is have 2 of these written right next to each other. And what we can go ahead and do now is to FOIL. So to FOIL these, I'll do that foiling work on the side. We're multiplying your first 2 terms together. So x times x. There are 2 of them here, so 1 plus 1 makes x squared. Then you multiply your first term and your last term, so the 2 outer terms. So we have plus x times a -4, which makes -4x. You do it again with your 2 inner terms. So you're just distributing this first term to each of those, and then do it again with your next term to each of these. So -4 times your x to make -4x. And your last one, your 2 last terms, so you have -4 times -4 for -16. Now, most likely, the middle 2 terms are going to combine to make x squared -8x. Oops, and that should be a plus 16 because both 4s are negative. So you have x squared plus 8x plus 16 minus 5. And then you can go ahead and combine those like terms. Now, if you wanted to change it back to a 3, don't subtract this 5 yet. Just write an extra one of these to be cubed. And we already did the foiling of the first 2. So then if you wanted, you can FOIL it again one more time and then combine your like terms. Again, that is your response. So P of A is equal to x squared plus 8x plus 11. All right, let's try it again. I'm going to change W to have a squared term as well. So you have W times A squared plus 3. Now we're changing your A to be A plus 4. So let's go ahead and work that in. A plus 4, A plus 4. Now you have 2 of those plus that 3. To FOIL, we should get at the end. Now, if you want to work on your FOILing, please pause video and try out your FOILing. We have A squared plus 4A plus 4A plus 16 plus 3. So to combine your like terms, W of A plus 4 is equal to A squared plus 8A plus 19. All right, so I'll leave the rest for you guys to finish out. Again, here is your answer. You'll notice that 17 and 12, we adjusted just ever so slightly.